Hello, Wayland Middle School. It's Mr. Farley here with another award-winning video. This time we're going to be talking about different types of solutions that can occur when solving a system. So the first one that we're going to look at is a really good one. It is when we have no solution. All right, and this always causes a little curveball for some kids, but if you pay close attention to this, you'll figure it out quite easily. So the first thing I want us to do, if you're given a system with both equations in slope-intercept form, we might as well give it a shot graphing, especially if you have a nice graph right next to it. So here we go. The red line I'm going to graph right now, this first one, has a y-intercept of -3. There it is. And a slope of 2. 2 can be written as 2 over 1. Tells me to rise 2 and run 1. I'm going to do that a couple of times. And I'll do it a couple of times down here. And ta-da, there's my line. Okay, so that's the red line. The blue line, which I'm going to try to graph right now, is also in slope-intercept form, has a y-intercept of 2. Going to plot that point right here. Also has a slope of 2. 2 over 1 tells me to rise 2 and run 1. Going to do that a couple of times. Draw my line. And right now, bells, whistles, sirens, and strobe lights should be going off in your head because these lines are parallel to each other. If there was going to be a solution to this equation, these lines would intersect at a specific point. This will never happen. If the lines are parallel, that will never take place, okay? That point of intersection won't happen. Therefore, we call it no solution when that happens. Now, Mr. Robinette in his last video showed you how to solve this by substitution, and I just want to kind of make that connection. What you can do is pick one equation that has a variable by itself already. And I have this right here. Y is by itself. So y is equal to 2x minus 3. This tells me that y is the same thing as 2x minus 3. Every time I see a y in the second equation, I'm going to plug in 2x minus 3 in its place. So I'm going to substitute it in. So y turns into 2x minus 3. And then I'm just going to copy the rest of the equation. Is equal to 2x plus 2. I have variables on both sides that are exactly the same. Those will cancel out. And I'm left with -3 is equal to 2, which we know is not true. That cannot happen. That tells us there's no solution. Okay, so you can see how a system can show us no solution graphically. On a graph, you can see they're parallel, they'll never intersect. And you can also see it here in purple with the algebra here. Through substitution, we find out that there is no solution here. I think that's pretty cool. So that's one thing that can happen. Okay. Second thing that can happen is that we have an equation that gives us one solution. Okay. Now, I think everyone is probably thinking if there's one solution, these two lines better intersect each other. I'm going to test it. Y-intercept 1, slope is 1. Remember, there's a little magic 1 right there. 1 over 1 tells me to rise 1, run 1. Going to do that several times. Also going to back it up this way here and continue that line. And there you have it, a beautiful line is right there. Second one, sadly, is not in slope-intercept form, but we can do that easily by subtracting an x from both sides. You get -x minus 3. This tells me the y-intercept is -3, which I'll graph. It tells me the slope is -1. Remember, there's really a 1 in front of that x, so -1. I like to call that -1 over 1. Down 1, right 1, down 1, right 1. And I can also back that up this way, draw my line, and both of them are perfectly straight, as you can see. And they intersect at exactly 1 point. That means there is one solution, okay? One solution here. And that solution is the point of intersection, which happens to be the point -2, -1. Okay. And one other thing we can do if you are interested in seeing, I could do this through substitution also. All right, let me just quickly plug this in and we can see what's going on. We have an equation that has a variable by itself already. Y is equal to 1x plus 1. That means whenever I see a y in the second equation, I can turn it into x plus 1. That's the substitution. So I have an x, I write an x. I see a plus, I write a plus. I see a y, bells, whistles, sirens, and strobe lights go off, and y is going to be replaced with x plus 1, and that equals -3. Okay, I copy this equation exactly the same, but I substituted in the value for y. So now when I solve it, I have an x and an x, gives me 2x, plus 1 is -3. Subtracting 1 from both sides, I get 2x is equal to -4, and now dividing by 2, x equals -2. Once I know x is -2, I can come back up here, plug it into the equation. If x is -2, I get -2 plus 1 is equal to y. And if I do that math, -2 plus 1 is -1. So my x coordinate is -2. My y coordinate is -1. And you can see that's the exact point of intersection we see here on the graph. So now you can see it graphically and you can see it algebraically using substitution. Pretty cool. Let's do one last one. Last one right here. Let me erase and move on. Actually, let me do that and clear this up. So here we go. So let's go to infinitely many solutions. This one's pretty good. All right, pretty good. Let's see what happens when I solve this. Infinitely many solutions. Y is equal to x plus 1. I'm going to graph it. It's in slope-intercept form. Y-intercept is 1. Slope is 1. Remember that magic 1. Slope of 1 means 1 over 1. Rise 1, run 1. Rise 1, run 1. Do that and make your line. There it is. Red line, done. Let's go to this blue line. Oh my goodness. This is not in slope-intercept form, so I'm going to add 2x to both sides. First, I get 2y is equal to 2x plus 2, dividing by 2. And don't forget, we've talked a ton about this. This 2 goes to both, and I get y equals x plus 1. If I were to graph this blue equation, the y-intercept is 1. Oh boy, that's the same y-intercept as the other one. The slope is 1. Uh-oh, wait a minute. That's the same slope as the red line also, up 1 over 1, up 1 over 1. And if you notice, the red line and the blue line are exactly the same line. Well, if you think, well, how many points do both the red and the blue line have in common? I hope your answer is there are an infinite number of points that the red and the blue line have in common. Okay, they overlap, so they match up on every single point on that line, leading us all the way to infinitely many solutions. And that's the way you can see it. So if you see it graphically, one line on top of the other, that means infinitely many solutions. Just want to do one last thing here for you. Let's just see what this looks like algebraically. So let me get rid of this for 1 minute, just clearing this away. Let's solve by substitution that Mr. Robinette taught us in one of his great videos. And here it is. Remember, with substitution, you want to find an equation that has an x or a y by itself. The top one has that. Y is by itself. Well, what does y equal? It equals x plus 1. That means every time I see a y, I'm going to replace it with x plus 1. Well, I don't see a y in the first part, but I do see a y here in the second. Y is turning into 2x plus 1. And then I just copy the rest of the equation. Let's simplify the left side. By distribute through, I get 4x plus 2 is equal to 2. Okay, and let's put these together here for a minute. Oops, I think I made a mistake right here. I'm just going to fix this. Sorry about that. right here, this should not be a 2x plus 1. That's just an x plus 1. You can see right up there. So a little mistake there, which I'm going to fix on the fly. So when I distribute this, I get 2x plus 2. When I distribute this through, sorry about that mistake. And when I continue simplifying, my x's cancel out, and I'm left with 2 equals 2, which you know is true. And what happens when an equation, when the variables cancel out and you're left with a true statement, that means all real numbers, which means infinitely many solutions to the system. So now you can see it graphically and you can see it algebraically. Again, I think it's pretty cool. Pretty cool. Last one, just a summary. You can use this to check this out at any time. So please remember, if you have one solution, the lines will intersect at exactly one point. If you have no solutions, the lines will be parallel to each other and will never intersect. Because of that, there will be no solution. And finally, if the lines are exactly the same, if it is the same line, both of them one on top of the other, we will have infinitely many solutions. So hopefully you learned a little bit with this video. Feel free to check in with Mr. Robinette or I. We'll get back to you with any answers to any of your questions. Thanks for listening. Hope you enjoyed.